Good morning, everybody. Hopefully, everybody had a good weekend. Got about 3 weeks here to go, so we're getting down to it. This is probably the last new lesson that we'll cover this year, depending on how it goes. And it is an important one, so we'll probably just spend the rest of the time reviewing it. It goes along with what we've been covering, factoring. It's section 8.6. The difference is if you look up here, the first coefficient is not 1. It's a number greater than 1. So learning target just says after this lesson, we'll be able to factor trinomials. That should say of the form ax squared plus bx plus c. So same thing we've been doing, but just a little bit tougher. So let's go ahead and get down to it. So the way I'm going to cover this is we're gonna do factoring by grouping, which you'll have to do 8-8 before you do this one because it's kind of different, and that's what we'll be using here. I'm going to show you an alternative method on how to do this, maybe tomorrow or maybe next week. So look for that too if you don't really like this method. So the first thing we want to do is figure out what multiplies to a times c and adds to b. All right, so similar to stuff we've seen in the past. So a times c here means 5 times 2. So that equals 10, and then b is just the coefficient of your middle term. So b is 11. So what multiplies to give me 10 and adds to give me 11? That's going to be 10 and 1. All right, so what do we do with that? What do we do with that 10 and 1? So basically we split this middle term up into the sum of two terms. So we're going to rewrite this as 5x squared plus 10x plus 1x, or just x, plus 2. Now, one question you're going to want to ask is, how do you know to put the 10x before the x? And the answer is it doesn't matter. So when we factor by grouping, yeah, it doesn't matter there. So remember, now we're thinking, what's the GCF of these two? That'd be 5x. And then we'd be left with x plus 2. And then look at the last two terms. What's the GCF of those? Nothing. So we just write plus 1 times the quantity x plus 2. And so our final answer is the quantity 5x plus 1 times the quantity x plus 2. So remember, you know, in 5, we could just assume it was going to be x plus or minus something times x plus or minus something. Not the case here. So you can see how these are just a little bit tougher. Anyways, next one. So a times c here equals 6 times 5 is 30. And then b is 13. So what multiplies to 30 adds to 13? That's going to be 10 and 3. So we go 6x squared plus 3x plus 10x plus 5. And the order there didn't matter on the first two. Notice I said 10x and 3x and then wrote them the other way because it just doesn't matter. And remember, we picked those because 3 times 10 is 30 and 3 plus 10 is 13. Okay, so now we're factoring by grouping. So what can I take out of 6x squared and 3x? That'd be 3x. And that would leave me with 2x plus 1. Out of these two, I can take a 5. And that's going to leave me with 2x plus 1. And remember, when we factor by grouping, we always have to see that repeated factor. If not, we've gone wrong somewhere. So final answer here, the quantity 3x plus 5 times the quantity 2x plus 1. I'm going to skip over C because it's similar to these two, and you can see it worked out in the notes. So example 2, always a little bit tougher when we throw in a negative. That's been true the whole time, so nothing new here. So A times C in this case, 3 times negative 15 is negative 45. And B is 4. So what multiplies to negative 45 and adds to 4? So now I'm thinking which two factors of 45 has a difference of 4? And that would be, I think, 9 and 5. So which one needs to be positive? That would be 9 because our sum is positive. So we said 9 and negative 5. So we're going to split that middle term into 9x minus 5x, or negative 5x plus 9x, either way. So 3x squared plus 9x minus 5x minus 15. All right, so out of the first two, I can factor a 3x. And that's going to leave me with the quantity x plus 3. Out of the second two, remember when that lead term, if I'm talking about these two, this is my lead term, negative 5x. If that's negative, I've got to factor out a negative. So I don't factor out a positive 5 here, I factor out a minus 5. And that's going to leave me with x plus 3. And you know, you can tell it wouldn't be the same if I factored out a positive 5. It would give me negative x minus 3. So that's not what we want. That doesn't match up. So final answer here, the quantity 3x minus 5 times the quantity x plus 3. All right, do one more like this. 10y squared plus 31y minus 14. So a little bit bigger numbers here. A times c, that's 10 times negative 14, which is negative 140. And b is 31. So this might be a good time to, grab a calculator and let that do the computation for you. So some factors of 140. So let's say 140, obviously 2 goes into it. 2 and 70 though, those don't have a difference of 31. So it needs to be a little bit bigger. So let's see if 4 goes in. 4 does. And 4 and 35 have a difference of 31, which is what I'm looking for. So which one of those is positive? Well, if my sum is positive, then I want the 35 to be the positive factor and the 4 to be the negative factor. So just kind of show you my thought process there to come up with the 35 and the negative 4. So 10y squared, just show you that order doesn't matter. I'll do the minus 4x first, and the plus 35x over here. So out of these two, I can factor, sorry, those are y terms, x terms, usually use an x. So anyways, out of these two, I could factor a 2y, and I took positive because my first term's positive, and that's going to leave me with times 5y minus 2. And then out of these two, I can factor out a 7. Again, that's positive because my lead term is positive, and that's going to give me 5y minus 2. Always good when you see that repeat. So final answer, the quantity 2y plus 7 times the quantity 5y minus 2. And I don't think I've reminded you guys of this last time, but it's always good to remember what we're doing here, right? We're saying that this times this equals this, right? So we can always multiply back out to see if that's true. So just to show you that real quick, 2y times 5y, gives me 10y squared. 2y times minus 2 gives me minus 4y. 7 times 5y gives me plus 35y. And 7 times negative 2 gives me negative 14. And we can see that, that looks familiar. That's kind of how we split it up right there. So that's kind of shows you what the process is. And anyways, when we combine these two terms, we get that final answer. So just for time purposes, I'm going to skip example C, but it is on the notes. So do the word problem. It says the area of a rectangle it's going to be length times width. It's given by the trinomial 2x squared minus 13x minus 7. So remember, that's equal to area. What are the possible dimensions of a rectangle? So dimensions of a rectangle, that's just the length and the width. So that just is asking me to factor. So A times C, positive 2 times negative 7 is negative 14. And then B is negative 13. So what's going to multiply to negative 14, add to negative 13? That's going to be negative 14 and positive 1. So first step is to rewrite this as 2x squared minus 14x plus x minus 7. And then we go from there. So these two factor out of 2x. And that's going to give me x minus 7. And then out of the last two, no common factors, so just a plus 1 times x minus 7. So our final answer, 2x plus 1. And they kind of, on these, on Math Excel, they don't want you to list them in parentheses, so you just say 2x plus 1 and x minus 7. That's how they want you to do your answer on those. For whatever reason, I wouldn't get too hung up on that. Same process. These last three, I might work all those out because it's super important. So this becomes really important after this lesson because this will really throw you off. So on these, you factor GCF first. So I didn't really mention this as I was working through, but you always have to look first, is there GCF? So in all these, the answer is going to be yes. So what is my common factor of all three of these terms would be 3 here. So we want to factor that out first and go 3 times the quantity 6x squared minus 11x plus 4. And now our job got a lot easier too. And I'm going to ignore that 3. Just remember it on your final answer. So I'm going to ignore that until the end. So we're just looking inside the parentheses as far as our factoring goes. A times C here is 6 times 4 is 24. And B is negative 11. So positive product, negative sum. I have, that'd be negative times negative. So here that'd be negative 8, negative 3. So we want to rewrite this as 6x squared minus 8x minus 3x plus 4. Out of these two, I can factor out a 2x. That give me 3x minus 4. Out of these two, I can't factor out anything, but this is key. Well, attention to detail. My first term is negative, so I want to factor out a minus 1 instead of a plus 1. Which gives me 3x minus 4. So then we just, it was nice to write that 3 down, at the beginning so we don't forget it in this last step. And then my other two factors are 2x minus 1 and 3x minus 4. Okay, so don't forget that GCF if possible. So what can I take out of all three of these? That'd be a 4. So 4 times quantity 2n squared minus 9n minus 5. And our side work here, a times c, 2 times -5 is -10. And then b is -9. So what adds to -9 multiplies to -10. That would be -10 and +1. So there we go. We're ignoring the 4 until the end, just so we don't have to write it a bunch of times. So my factoring work goes 2n squared minus 10n plus n minus 5. Out of these two, I can factor just a 2n. And that's going to give me 2n. And then nothing out of these two, so 1, and then we have it. So two other factors besides the 4 are 2n plus 1 and n minus 5. And I will go ahead and skip this one since it's on the notes anyways. Don't want to take up your whole day here. But this will be a tough lesson and we'll go over it a bunch. So don't be afraid to ask questions and don't be afraid to explore some of those resources out there on the web. All right, guys. So have a good day. Enjoy one of your last weeks of school and keep working hard, finish strong. And as always, I appreciate your hard work.